Okay. Guys, those who are online, you're able to hear me, right?
Yes, sir.
Okay. So we solved the first 10 problems yesterday. Right? I hope they were simple only. Shall we move on to the next part? Okay, we'll start with the 11th one. So they're asking us the value of the following: tan inverse 1 plus cos inverse of minus half plus sin inverse of minus half. So find the individual principal values and add them. So what is tan inverse 1, guys? 5 by 4. So is there anyone who wants explanation for it? You know how to write it in the exam, right? So tan inverse 1, you take it as y, and then you do all those steps and show it. So that depends on the marks of that particular problem. If it is 2 marks, you can directly write it as 5 by 4 and all other things. If it is 3 marks or something, then you need to show the steps. Let's start. Tan inverse 1 and a positive, right? It is in first quadrant. So it is 5 by 4. Can I go a little faster with respect to these problems? Right? 5 by 4 plus cos inverse of minus half is 5 minus, it is 2 pi by 3. Is everyone convinced with it? You're convinced? 2 pi by 3? Yeah. 2 pi by 3 plus sin inverse of minus half. 5 pi by, but 5 pi by 6, how did you get it? It is minus pi by 6. Yes. It is minus pi by 6. So pi by 4 plus 2 pi by 3 minus pi by 6. Take LCM, solve it and tell me the answer. Faster. Do it fast. So both of you got same answer and trusting it. 3 pi by 4. Okay. What about the next one? Cos inverse half. Cos inverse half, guys. 5 by 3. Sin inverse half. 5 by? Correct. 5 by 6. But you have 2 times this thing. So 2 into pi by 6. Both of them are supposed to be added. Pi by 3 plus pi by 3. Pi by 3 plus pi by 3 over 2 pi by 3. It is clear? Next one. Sin inverse x is equal to y. Then the value of y belongs to. They're basically asking you the definition of range. What is the range of sin inverse x? Option B, minus pi by 2 to pi by 2. Both are included. If you see B and D are closer, but what is the difference? Inclusion. Right? Similarly, 14th one. Tan inverse of root 3 minus secant inverse of minus 2. Tan inverse root 3 euro. Pi by? Correct. It is pi by 3. Minus is there. Secant inverse of minus 2. Right. I'll give you time. Secant inverse of minus 2. I know the answer. Correct. 2 pi by 3. So pi by 3 minus 2 pi by 3. Answer is going to be minus pi by 3. Is there anyone having doubt of why secant inverse minus 2 is 2 pi by 3? Anyone with a doubt? Everyone is convinced? Right? See those who are online, any doubt? Okay, I'm assuming it is clear. Okay, very good. So now next, we will get into the next exercise. That is, we are going to see the properties of inverse trigonometric functions. Right? See, I told you one thing. If f of x is equal to sine x, then what is f inverse of x? F inverse of x another. Sine inverse x. Okay. They both can be inverse of each other such that f of f inverse of x is x. Are you in agreement with this? So I meant sine of sine inverse of x is equal to x. In a similar way, sine inverse of sine x is also x, accepted. That is, f inverse of f of x is also x. But here one confusing factor is, in both the cases I'm writing it as x. So what does that x value get confined to? Where is the x value coming from? See, for example, if I take sine of sine inverse of x is equal to x, then what does this x belong to? Huh? Why? How did I find it out? This is minus 1. Because what will I substitute inside an inverse? I told you yesterday, angles and values. Okay, what will I substitute inside inverse? I'll substitute a value, and that value will generate an angle. So sine of sine inverse of x is actually x, and that value of x that you're going to get is between minus 1 to 1. Correct? Adhe mari sine of sine inverse of x, what will I substitute inside sine, inside a trigonometric function? I'll substitute angle. Here x belongs to minus pi by 2 to pi by 2. Does that make sense? Right? So if you observe, they both are very close to each other, except the fact that you need to know what value of x is to be defined. Please make a note of it. Okay. Clear? Subrajit, clear? Question. What is your name? I forgot. Harshini only. Harshini. You're clear? Tarush and Dinesh. Clear? Okay. Shall we get started? Now we'll get into the first property. See, these are all very, very, very simple properties. First one. In the first set of properties, you have a question based like sine inverse of 1 by x. How will you write it in terms of cosecant inverse? So generally, these are all the inverse trigonometric functions which are related. Sine inverse is related to cosecant inverse. Tan inverse will be related to cot inverse. Secant will be related to cosecant. Sorry, cosine, right? Cos. So if I take sine inverse of 1 by x, my job is to write it in terms of cosecant x. Listen to this carefully. Now, as of now, I'm not concentrating on the domain part. I'm only concentrating on the conversion part. So I told you there is only one way to solve it. The given function by default, take it as y. What trigonometric function you should consider on both the sides? Take sine on both the sides. Sine of sine inverse of 1 by x is equal to sine y. So 1 by x is equal to sine y. Accepted. What is that you actually need? You need the value of y. So let me call this as equation number 1. So 1 by x is sine y. Then what is x equal to? 1 by sine y, which is cosecant y. Now I want y on the right hand side. So what should I consider on both the sides? I consider cosecant inverse on both the sides. Then left hand side is going to be cosecant inverse x is equal to cosecant inverse of cosecant y is y. Let me call this as 2. So first one is telling me y is equal to sine inverse 1 by x. Second equation is telling me y is equal to cosecant inverse x. Since right hand sides are equal, can I say left hand sides are equal? Accept. So that's what happens. This is how you prove. Here. So please make a note of it. Try to write it without seeing. No. I'll give you a minute time. Can you try proving cosecant inverse 1 by x is equal to secant inverse x? Sorry, not cosecant, cos. Cos inverse 1 by x is equal to secant inverse x. Equation is a number. Always take the question as equation number 1. You able to understand that? Right. Sign inverse is okay. Try the next one. Near proof. Correct. You told her. Simple only, right? So you should get used to it. What happened? Got stuck. Second one, property. You have the next one. Second property, cos inverse of 1 by x. Got it? That's question. That's one for equation. Cos inverse 1 by x is equal to y is equation. Question 1 is equal to y. That's it. You got it? Sure. That's so try the next one. Make it fast. Those who are online, you're able to do it?
Yes, sir.
Right. If there is any doubt, please ask. So I'm assuming that everybody got this. So these are the steps. Cos inverse of 1 by x, you will assume it to be y. Take it as equation number 1. So cos inverse of 1 by x is equal to cos y. So 1 by x is equal to cos y. But x will be equal to secant y. So secant inverse x is equal to secant inverse of secant y. So this will be y. This is secant inverse x. Take this as 2. From 1 and 2, you can say cos inverse 1 by x is secant inverse x. Okay. Now you can ask me a question. Can we use this logic in the previous exercise? So just because we are learning the properties now, it is not necessary that you cannot use this logic in the previous exercise. For example, this is there tan inverse of root 3 minus secant inverse of minus 2. Generally, we are comfortable with sine, cos, and tan. So secant comes, it slightly disturbs us, right? I've seen for most of the people. So tan inverse root 3 minus secant inverse minus 2, according to the same logic, what can you write it as? Cos inverse of minus half. So this is how I found it is 2 pi by 3. So again, if you try to solve this, this will be pi by 3 minus cos inverse of minus half another. Same 2 pi by 3. Values can't change. Answer will be minus pi by 3. Now what you can do, if you revisit the first exercise, wherever cosecant, secant, and cot are there, you can use this logic and solve the problems. So when it comes in the exam, not necessarily you have to use the logic of only first exercise. You can use the properties. Is that clear? So you understood why you are studying in the first place? Yes? Right. I'm not yet concentrated on the domain. If you look at the domain, sine inverse of 1 by x is equal to cosecant inverse x. So I need to take the value of x from whom? Sine inverse or cosecant inverse? Domain, where should I take it from? So you take the domain always from the one which where the x is in the numerator. So cosecant inverse, what is the domain of it? Real numbers except minus 1 to 1. They forgot what will be the domain of this real number except minus 1 to 1. Yesterday we discussed, no? Or minus infinity to minus 1 union 1 to infinity. That's what they've given it like this. Or none other, or is union. Or means union. You're able to understand. So what have they given? X greater than or equal to 1 means 1 to infinity, or means union 1 to infinity union minus 1 minus infinity to minus 1. This is the meaning of that statement. They've given it in greater than and less than and confused. So I've written three values: r minus open bracket minus 1 to 1, or minus infinity to minus 1 union 1 to infinity, or x greater than or equal to minus 1, or x less than or equal to minus 1. All the three mean the same. You're able to understand. Similarly, cos inverse of 1 by x is equal to secant inverse x. What is the domain be? You take the domain of secant inverse x. You already have the table with you. You need not ask me. You have the table with you. What is it? Same as that of cosecant inverse. Minus infinity to minus 1 union 1 to infinity. Same logic. What will tan inverse 1 by x give you? It will give you cot inverse x. So cot inverse x domain is a delay here. So second property is they have given greater than 0. But actually it can be r according to the logic. Because, see, for example, I have cot inverse of minus, let's say, minus root 3. This is same as tan inverse of minus 1 by root 3. Actually, it can be r. So let me check it with some other book and tell you. To my knowledge, it is r only. I'm not sure why they have given it as greater than 0. Because it's the same thing. Tan inverse of minus 1 by root 3, what are you going to get? Oh, wait. That's right. Actually, I'm sorry, it was my mistake. That's right only. Because tan inverse of minus 1 by root 3, what will you get? Tan inverse of minus 1 by root 3 will get minus pi by 6 accepted. Whereas cot inverse of minus root 3 will give you what? Pi minus pi by 6. It is 5 pi by 6. It is not the same. Because think of the logic. Yesterday, I told you an important logic. You remember when you were solving the problem, you have to look at the kind of inverse trigonometric function and then find it out. Okay. See, if I take, there are three functions. There are three inverse trigonometric functions which have the domain as minus pi by 2 to pi by 2. What are they? Sine, cosecant, tan. Correct? So if you look at the first one, sine inverse and cosecant inverse are getting related to each other. So when you're going to find the value, both will be generating the value between minus pi by 2 to pi by 2 only. That is why you took the domain of cosecant inverse. Similarly, when you look at the other trigonometric functions, which has the values between 0 to pi, what are they? Cos inverse, secant inverse, cot inverse. So cos inverse and secant inverse belong to the same group of 0 to pi. So what I'm trying to say is, sine inverse and cosecant inverse belong to the same group of minus pi by 2 to pi by 2. Are you able to understand? Similarly, cos inverse and secant inverse both belong to the group of 0 to pi, whereas tan inverse and cot inverse are contradicting. Because tan inverse belongs to minus pi by 2 to pi by 2, cot inverse belongs to 0 to pi. That is the reason why tan inverse of 1 by x is equal to cot inverse of x. You can do that only when the value of x is greater than 0, or else you will get a wrong value. Please make an important note. So I hope you understood with this logic, right? Here you are getting 5 pi by 6, whereas on the right hand side you are getting minus 5 by 6. So did you understand the logic, guys? Why is it happening? Because they both have different domain ranges. One is between 0 to pi, one is between minus pi by 2 to pi. That is why you restrict it to positive values. Got it? I take the next set of property. Sine inverse of minus x is what? Minus sine inverse x. Yesterday I told you one thing, right? See, unnecessarily it got complicated. It got complicated because I had to tell you about the family of minus pi by 2 to pi by 2 and then find the positive value and put a minus sign. Right? Instead, what you could have done is, for example, if the question is sine inverse of minus half, according to this property, what is it? It is minus sine inverse half. So you already know what is the value of sine inverse half. How much is it? Pi by 6, put a minus. So it is minus pi by 6. That's what the property says. But when we did it yesterday, what did we do? We had to go to the domain. And in the domain, then we need to start thinking of the logic and all those things, right? But it makes sense, right? Whatever we did yesterday makes sense because you understood the concept of quadrants. But is there a shortcut or a faster way to solve this? It is this property. Okay. So sine inverse of minus x is equal to minus sine inverse x for all values of x that belongs to minus 1 to 1. Similarly, tan inverse of minus x is minus tan inverse x for all values of x that belongs to real numbers. Similarly, cosecant inverse of minus x is equal to minus of cosecant inverse x. Again, they gave one more thing to confuse you. Whatever, modulus of x is greater than or equal to 1. That also means minus infinity to minus 1, union 1 to infinity. This is another way of writing. So same thing, look at the way they are presented, no? R minus of minus 1 to 1, minus infinity to minus 1, union 1 to infinity, x greater than or equal to 1, x greater than or equal to 1, or x less than or equal to minus 1, or mod x is greater than or equal to 1. All these things fall under the same branch. They all mean the same.
X will be minus less than minus 1.
Idra?
Last one.
Okay.
Modulus of x should be greater than equal to 1.
Mod x, put a definition. It is x when x is greater than 0. Correct? It is equal to 0 when x is less than 0. It is minus x when x is, sorry. X is greater than 0 when x is equal to 0, and this is when x is less than 0. Are you accepting this? Why did I write a minus x? Because when x is less than 0, what value are you going to have? You are going to have a negative value, right? So negative of negative value is what is generating the positive. That is the logic that they have used. So mod x is greater than or equal to 1 means this is a logic. So from this logic only you are trying to break it as mod x is equal to 1. What is the value of x? It is actually plus or minus 1. This is what you need to understand. It is plus or minus 1. The same thing is applicable for inequality. Modulus of negative number, modulus of minus 5, you are actually writing it as 5. Your end user, Mary. But what is happening in the back end? It is actually becoming from the definition comes from, so you need to check, you need to go to the basic definition of modulus and understand minus 5, FT plus 5 are there. Because minus 5 is a value less than 0, then how are you supposed to write the modulus as minus of minus 5, none other than the plus 5? It's not like the minus is getting cancelled. As a basic definition, that's what it is saying. So x is equal to plus or minus 1. So when you take this plus or minus 1 and substitute it in say modulus, 1 is meaning. The same thing is applicable for inequality as well. So generally, you will have some places where mod x is less than or equal to 1. So mod x is less than or equal to 1. It means x belongs to minus 1 to 1. So this is based on Wavy curve method. Again, if I start explaining it, time waste. That is why I'm restricting myself. Okay. So you're able to understand mod x is greater than or equal to 1. You are going to restrict between, so you're going to take the values less than minus 1 and greater than plus 1. That is the meaning. mod x is less than or equal to 1, the meaning another. You will take the values between -1 to 1. So what I'm trying to say is here you have no this x belongs to -1 to 1. This is the same as mod x is less than or equal to 1. There's another way of writing. If you want, you can make anyway. So for example, mod x is less than or equal to 2. What is the meaning of this? -2 to 2 within the bracket. Otherwise less than abdin strict about a open bracket. That is it. Why it is so, we'll see it in continuous functions. And at that point, I'll explain. There I have to definitely explain wavy curve method. Okay. So as of now, we'll go with the properties. So are you guys able to understand? So sine inverse of minus x is minus sine inverse x. Tan inverse of minus x is minus tan inverse x. And cosecant of inverse of minus x is minus cosecant inverse x. All are with respect to the respective domains of the inverse trigonometric functions. Sine inverse, tan inverse, and cosecant inverse. Then you have another set of property. Cos inverse of minus x. It is not minus cos inverse x. Rather, it is pi minus cos inverse x. So, but now you know the logic of why that pi minus is coming. Okay. Before that, we will prove this thing. So, sine inverse of minus x. Okay, all the problems in this chapter, by default, the first step is always the same. Take it as y and mark it as equation number 1. What should you take on both the sides? Sine. So, sine inverse of minus x is equal to sine y. So, minus x is equal to sine y. Up x another. Minus sine y. So, this will be minus, or can I write it as sine of minus y? Right, this is x. So what should I take on both the sides? So sine inverse of x is equal to sine inverse of x is equal to sine inverse of sine of minus y. So sine inverse of sine of minus y is minus y. This sine inverse of x. Bring the minus sign this side. This minus sine inverse x is equal to y. Equation number 2. See, the number of steps are big, but the logic is simple. So if you look at the first one and second one, it's saying sine inverse of minus x is equal to minus sine x. Since you have to prove, I wrote it as minus. Is that what you're thinking? Sine of minus y. That's what I thought you'll ask this question. It's a valid question, right? It is looking as if I wanted to prove something and I wrote it, right? But that's not the logic. See, sine inverse of minus x is equal to y, you are saying no. What is the range of that y? What is the range of y? It is between minus pi by 2 to pi by 2. So I'm revisiting in trigonometric functions. Okay. I know the fact that if I have sine of minus x, it is minus sine x. Now I'll do the reverse analysis. If I have minus sine x, right, I could have written it as sine of minus x. That is one of the options. Or I could have written it as sine of pi plus x. Or I could have written it as sine of 2 pi minus x. Yeah, actually your question is bottling down to this value. So why didn't I choose the next two? Now you think of the logic and tell me. Pi plus x is third quadrant. Huh? Sine in third quadrant is negative then. Huh? So it is minus sine x. Does that make sense? So I gave three logics. Sine of minus x, sine pi plus x, or sine 2 pi minus x I could have written. Yeah, why didn't I take the next two? Because if I revisit if I look at the table is telling me my value of y is supposed to be belonging to minus pi by 2 to pi by 2. So if I take minus pi by 2, it belongs to fourth quadrant. I could have write so 2 pi minus x, if suppose x is an acute angle, what will be the value that you will get? For example, sine inverse of minus half. Okay. So had it been plus half, sine inverse of half na x value 5 by 6 or 2 pi minus 5 by 6 over 11 pi by 6. That's 11 pi by 6 belong to minus pi by 2. That is the reason. So that is the reason why I wrote it. It's not true. Logic. How many of you didn't understand? Half-baked understand. Half-baked, correct? See, you need to be good with trigonometry for this thing. You need to answer one question to me. Sine of minus x, what does it mean? If I give you a question, sine of minus x, in anti-clockwise direction, I have entered into the, in the clockwise direction, I have entered into fourth quadrant, accepted, right? Sine of pi plus x, what does it mean? In the anti-clockwise direction, I have entered into the third quadrant. Sine of 2 pi minus x. In the anti-clockwise direction, I have entered into the fourth quadrant. Anti-clockwise. In anti-clockwise direction, I have entered into the fourth quadrant. Logic is simple. Let's see. Provided the value of x that I am taking is an acute angle, have that in mind. Is an acute angle. See, let me say there is a line like this. Okay. Let me call it as a vector for the time being. If I say this line is making an angle x here, right? So what will this angle be? Either 2 pi minus x. How did I get this? If I make a full revolution, it is 2 pi. I made a revolution in the clockwise direction, which is x. So clockwise direction x in it is minus x. So 2 pi length, that minus x is 1. So that is why it is 2 pi minus x. Are you able to think that different? But why didn't I take 2 pi minus x? Because my sine inverse x value, the range value is telling me I can choose the angle from this point either in the clockwise direction till pi by 2 or in the anti-clockwise direction till pi by 2. That is why this angle became minus pi by 2 to pi by 2. So I am restricted to rotate myself when I enter into the fourth quadrant in a clockwise direction. That is why I didn't choose either of them. I didn't choose sine of pi plus x or 2 pi minus x. Rather, I wrote x is equal to sine of minus 1. That is actual back end meaning of it. If you have understood, well and good. If you have not understood, forget it. Okay, nobody is going to ask you in the exam. Forget it. Okay, but these are the steps that you need to follow. Same as the case with respect to tan inverse and cosecant inverse, because their range is also restricted to minus pi by 2 to pi by 2. I need to rotate in the clockwise direction or in the anti-clockwise direction. This is the theory involved in. I'm not taking the logic from inverse trigonometry. I'm taking the logic from trigonometry. So the basics of quadrants. Is that clear? No. So please copy this. If there is any doubt in the steps, please let me know. Let me know once you're done. Sandhya, you're done? Nitin, done? Yeah. Niranjan? Done? Copying it? Moving on to the next property. So what is the next property telling us? So when I say next property, I'm going to the next set. Third set. So they're saying cos inverse of minus x is equal to pi minus cos inverse of x. Logic is simple. Cos inverse of x, x value is positive there. So when you're taking cos inverse x, you will get an acute angle. That's what we did yesterday. See, for example, if it was cos inverse of minus half, what did I tell you? First find the acute angle. Acute angle? Pi by 3. Right? And I asked you to write it as pi minus pi by 3. You got 2 pi by 3. Same logic. Okay. Pi minus, if you take it like a formula or whatever you want, pi minus cos inverse of half. Does it make the same logic? So pi minus cos inverse of half is pi by 3. Both are giving you the same value. Okay. Now, I need to prove it. So cos inverse of minus x is equal to pi minus cos inverse x when you substitute the value of x between -1 to 1. So as I told you, the first step is always cos inverse of minus x. The question, take it as y. Mark it as equation number 1. Take the same trigonometric function. So cos of, can I skip that step? Can I directly write it as minus x is equal to cos y? So x is equal to cos minus cos y. So where all cos will generate a negative value. Second quadrant, third quadrant. Okay. So if you look at the domain of, if I look at the range of cos inverse, what is it telling me? The values are supposed to belong to 0 to pi. 0 to pi in the quadrants. First and second. So second quadrant, how is the angle written? Pi minus x. So since you are in agreement with me, can I write this as cos of pi minus y? I could have written it as cos of pi plus y also, but why did I write it? Because it goes into the third quadrant. Third quadrant does not belong to the range. So cos of pi minus y, I wrote it. Again, I take cos inverse on both the sides. So can I write cos inverse of x is equal to pi minus y? But what is y, guys? One minute. Sorry. Is equal to pi minus y. So y will be equal to pi minus cos inverse x. So this is equation number 2. The first equation, y is cos inverse of minus x. Second equation, y is pi minus cos inverse x. So they both are equal. Clear? Here, if you observe, the domains are with respect to those inverse trigonometric functions only. First, cos inverse of minus x is pi minus cos inverse x. What is the domain? -1 to 1. That is the domain of cos inverse. Secant inverse of minus x is pi minus secant inverse x. Domain is mod x is greater than or equal to 1. Domain of secant inverse. Cot inverse of minus x is equal to pi minus cot inverse x. Here domain belongs to real numbers. So where does the cot inverse have the domain greater than 0? We saw it at one point. Tan inverse of 1 by x is equal to cot inverse x. You can do that conversion only when the value of x that you have substituted is a positive number. That is this one. In the first property, the third subdivision. That is the only place where x is greater than 0. So that differentiation you should have it in your mind. Shall I move to the fourth property? Sin inverse x plus cos inverse x is equal to pi by 2. For all values of x that belongs to -1 to 1. So let's try to prove it. So if I take sin inverse x is equal to y, okay, then this implies x is equal to sin y, right? How can I write sin in terms of cos? Sin and cos are complementary of each other. So I can write it as cos of pi by 2 minus y. Now what should I consider on both the sides? Cos inverse x is equal to pi by 2 minus y. Accepted. So pi by 2 minus y na per y plus cos inverse x is equal to pi by 2. But what is y, guys? So from this, sin inverse x plus cos inverse x is pi by 2. There's a proof. Any doubt? Write it down. Similarly, what are the other complementary trigonometric functions? Tan and cot. So tan inverse x plus cot inverse x will give you pi by 2. Similarly, what are the other two? Cos inverse and secant inverse. So cos inverse x plus secant inverse x will also give you 5/2. So those are the other two properties. So did I say cos inverse? I'm sorry, cosecant inverse. Cosecant inverse plus secant inverse is equal to 5/2 because cosecant and secant are complementary of each other. So always keep concentrating on the domains. Okay, have that clarity. If at all they want to make the paper tough, the only point they can concentrate upon is domains. Surya. Next, fifth one is tan inverse x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus xy. Oh, how to prove this? See, observe. If I take tan inverse x as alpha and tan inverse y as beta, so can I say x is equal to tan alpha? I'll say y is equal to tan beta. So tan inverse x plus tan inverse y is alpha plus beta. Correct? So consider tan of alpha plus beta. What is tan of alpha plus beta? Tan alpha plus tan beta divided by 1 minus tan alpha tan beta. But what is tan alpha? X, x plus y by 1 minus xy. This another. This tan of alpha plus beta. But what do we want? We want only alpha plus beta. Then this will become tan inverse of x plus y divided by 1 minus xy. So by now, I hope you would have understood that you can combine trigonometry and inverse trigonometry to solve. If at all you are forgetting some formula in inverse trigonometry, you can always take the help from trigonometry itself. So similarly, tan inverse x minus tan inverse y, what is it going to be? Tan inverse of x minus y by 1 plus xy. That's it. Sharia. The last property that you have. That is sixth one. So sixth one, we are going to write it. If you observe the left hand side, all the three properties, what is that? You have 2 tan inverse x. So 2 tan inverse x, you try to write one time in terms of sine inverse, once in terms of cos inverse, and the third in terms of tan inverse. So that's what we are going to see. Okay. This is slightly an important one. I'll explain in detail. Sixth property, guys. First one, 2 tan inverse x is equal to sine inverse of 2x divided by 1 plus x square. Accepted. Right. So how to get this? So there is a formula like this. What is tan 2x? Can someone tell me? 2 tan x by 1 minus tan square x. So if I ask you, how did you get it? You know the answer. So tan x plus, tan of x plus x, right? Tan x plus tan x by 1 minus tan x into tan x. Correct? But how can you write the same thing in terms of sine? Or I'll say something like this. What is sine? 2 sin x? 2 tan x divided by, you know how it has come? Somebody told you, accepted. See, 2 sin x cos x. The logic is very simple. Okay. Whenever you want to convert sin to tan, what will you do? Divide by cos and compensate it with cos. So divide with cos x and compensate it with cos x. So 2 into sin x by cos x is 2 tan x into what you have in the numerator. Cos square x, I can write it as 1 by secant square x. But what is secant square x into other logic? So 2 tan x divided by 1 plus tan square x. If you observe, tan 2x and sin 2x will be very close to each other in terms of tan. Except the fact that the denominator of tan 2x is 1 minus and sin 2x is 1 plus. So if you observe the left hand side, right, 2 tan inverse x is equal to sin inverse of 2x by 1 plus x square. Is it not looking something similar to that? So what we will do is we will take RHS. I am taking the idea from RHS. Okay. Sin inverse of 2x divided by 1 plus x square. Now what I am going to do, I will say x is equal to tan theta. If I put x is equal to tan theta, implies theta is equal to tan inverse x. Accepted. So when this is called substitution method. In the place of x, I am substituting tan theta. So I need to get back theta in terms of x. So theta is tan inverse x. So when I take and substitute it here, I get sin inverse of 2 tan theta divided by 1 plus tan square theta. This is sin inverse of what? Sin 2 theta. So sin inverse of sin 2 theta is 2 theta. And what is this? Other answer. So that is why 2 tan inverse x is written as sin inverse of 2x divided by 1 plus x. Clear? So you can copy this. Yeah, you can. You take 2 tan inverse x, right? Put x is equal to tan theta and again try to solve it. It's unnecessarily, I don't want to confuse you. We'll go with one method. We'll go with this. Once you master this chapter, I'll tell you how to do from LHS. That point you will understand. As of now, follow this. Next one, what is it? 2 tan inverse x is equal to cos inverse of 1 minus x square divided by 1 plus x square. Is it not looking the format of cos 2 theta? What is cos 2 theta in terms of tan? 1 minus tan square theta by, how did I get it? Same logic. Cos 2 theta in the basic formula is cos square theta minus sin square theta. I want to write it in terms of tan. So divide with cos square and compensate it with cos square. So 1 minus tan square theta into cos square theta. I wrote it directly. Are you able to do it in mind? I divided with cos square. So 1 minus tan square theta into cos square theta. But cos square theta is 1 by secant square theta. So 1 minus tan square theta divided by secant square is, that is very important. 1 minus tan square divided by 1 plus tan square. Okay. Please make a note of it. Now we need to prove the second property. What is it? 2 tan inverse x is equal to cos inverse of 1 minus x square divided by 1 plus x square. Again, I'm considering RHS. So I'll take the RHS and I'll put x is equal to tan theta. Wherever you see 1 minus x square by 1 plus x square, it is looking in what format? 1 minus tan square theta by 1 plus tan square theta. Substitute it. So cos inverse of 1 minus tan square by 1 plus tan square. Cos inverse of cos 2 theta. This will give you 2 theta. This will be 2 other answer. Okay. What is the third one? 2 tan inverse x is equal to tan inverse of 2x divided by 1 minus x square. Correct? That is very simple. So 2 tan inverse x, you can write it as tan inverse x plus tan inverse x. Use the fifth property, you will get the answer. Purida, what did you understand what I mentioned? Third one is 2 tan inverse x is equal to tan inverse of 2x divided by 1 minus x square. So this now I am taking LHS itself. See, I can take RHS and also prove itself. Going to give you the same thing. So this one is simpler for me. 2 tan inverse x, I wrote it as tan inverse x plus tan inverse x. What is the fifth property telling me? It is tan inverse of x plus y divided by 1 minus x square. So it is tan inverse of 2x by 1 minus x square. That's it. Okay. So this is simplest logic. Okay. Shall we move on? Can we try a few problems? Right. Yeah, please tell. 2 tan inverse x. Tan inverse. So I can write 2 as a plus a. So tan inverse plus tan inverse. Fifth property another. You have textbook? Show him. Fifth property and the first one, show it to him. Tan inverse of x plus y by 1 minus x square. So in this case, both are x. So x plus x by 1 minus x square. Right? Now, see, as I told you, this chapter is very simple. Okay. Chapter is simple. Only thing is you need to master which value is to be substituted at a point. So I'll give you a hint. Okay, if you follow these techniques, you can solve any kind of problem. So this is the hint for substitution. First thing is, wherever you see 1 minus x square, you will find these kind of patterns only. 1 minus x square, 1 plus x square, or you will find x square minus 1. This is one set. So wherever you find 1 minus x square, what will you substitute x as? Recollect the trigonometric identities from your 10th grade. Sin square theta plus cos square theta is 1. So 1 minus sin square theta is cos square, 1 minus cos square is sin square. So in this place, you can put x as either sin theta or cos theta. Got it? Or cos theta. Similarly, 1 plus x square, recollect the identity. You can eat secant. You can substitute tan or cot because 1 plus tan square theta is secant square theta. 1 plus cot square theta is cosecant square theta. So you can either put it as tan or cot theta. X square minus 1. You can either put secant theta or all of the logic. Okay. So this is when you have the first as number 1. Sometimes there will be questions like a square minus x square, a square plus x square, and x square minus a square. So when you have a square minus x square, put x is equal to a sin theta or a cos theta. When you have a square plus x square, put x is equal to a tan theta or a cot theta. Prepare it like a table, okay? So it will be useful for the future reference. Then here you can write a is x is equal to a secant theta or a cosecant theta. Is that clear? Does that make sense? You can substitute and see. In the first one, if I substitute a sin theta, then what will I have? A square minus a square sin square theta. Pen a common hour. A square. You take out a square into 1 minus sin square theta. It is cos square. Clear? So I gave you all the hints possible. Now it's your turn to solve problems. So if you look at the very first problem in the example, what is the question? Show that, okay? Show that sin inverse of 2x into root of 1 minus x square is equal to 2 sin inverse x. What are they asking? Show that sin inverse of 2x into root of 1 minus x square is equal to 2 sin inverse x. So what can we do here is, I just gave you the hint. See, wherever you see 1 minus x square, you can either substitute sin theta or cos theta. In this one, what you want me to substitute? Want me to take sine? Where did you get the idea from? Sometimes what you can do is when they ask you to prove something, right? Look at the right hand side. So since it is sine inverse, it is advisable for you to substitute sine theta. But you can ask me a question: if I substitute cos theta, will I not get an answer? You will get. I'll do that also. I'm sure. Okay. So x is equal to sine theta. If I substitute, then I'll get. So I'm taking only LHS. Okay. I'll do it. So if I take sine inverse of 2 sine theta into root of 1 minus sine square theta, can I directly write it as cos theta? Or you want me to write an extra step? Okay, I'll write it. So 1 minus sine square theta. So sine inverse of 2 sine theta into cos theta. Up then the sine inverse of it is 2 theta. So x is equal to, so always when you're substituting, right, the first step itself, x is equal to sine theta. Now find theta in terms of x. And take this as, so 2a sine inverse x. Does that make sense? Got it. Right. But what did I say? You want to substitute. It is always challenging, right? So let's do that and see. X is equal to cos theta. So sine, I'm again considering only LHS. Let's say x is equal to cos theta, then implies theta is equal to cos inverse of x. So sine inverse of 2 cos theta into sine theta. Correct? So what am I getting here? So here it is going to give you the answer as 2 so there's going to be 2 cos inverse x. So that's what the next problem is actually. They asked us to get 2 cos inverse x. Right? So where this will help you is this kind of a problem is basically used in integration and differentiation. So at the point when you're performing indefinite integrals, you can use either of them. But here we are getting different answers. So what we can do is, when you're using indefinite integrals, so what will happen is 2 into, just sharing the idea. What is the relation between cos inverse and sine inverse? Look at the third property. Sine inverse x plus cos inverse x is pi by 2. If the same problem is given in indefinite integrals, you will write this as pi by 2 minus sine inverse x. But here we can't write it. So that is why I told you, with respect to inverse trigonometry based problems, the hint for what you are supposed to substitute will always be on the right hand side. So since here it is sine inverse, you need to put x as sine theta. Since here it is cos inverse, you can put it as cos theta. Whereas in the case of differentiation or integration, the same problem you're asked to differentiate, you can put either of them and you will get the same answer. So that logic we'll discuss at that point. But for these two problems, you understood?
So why would we be using the a square minus x square?
That depends on the problem.
What is the a?
A is some constant. I'll show you. Wait. Then here per 10th problem. 9th problem. There you use it. Okay. We'll do 4th problem. That will be the last problem for the day. 5th onwards, we'll start it tomorrow. I'll tell you how to think. Okay. Show that tan inverse of half plus tan inverse of 2 by 11 is equal to tan inverse of 3 by 4. You directly have a formula substitute. Tan inverse x plus tan inverse y. What is it?
Tan inverse of
X plus y. Perfect. Do it. Is it hard? So tan inverse half plus tan inverse 2 by 11. So you can directly write it as tan inverse of x plus y half plus 2 by 11 divided by divided by 10 divided by 11. Cancel it twice. So this will be tan inverse of 15 by 20 or 3 by 4. right? It's simple only, no? So application part is actually easy. Only concepts will take some time, especially the domains part. In tomorrow's class, we will try to complete this exercise. It's very simple. We'll finish it. Okay. Any other doubt from today's class? Clear only, no? So revise it and come. I would suggest you guys practice the derivation once again so that you are not confused. Today, you might feel you would have understood, but definitely you will have a confusion when you're going to place the paper. Place it on the paper. Okay. Try it out. Okay, that's it from my side. I'll see what. Guys, those who are online, any doubt?
No, sir.
Yes.
Okay. Okay.
Thank you, sir.
Yeah. Thank you.
Thank you, sir.